Cool. All right. All right, today we will be learning about scatter plots. And what those are is basically what you guys are doing when you just were given a domain to graph. It's just a bunch of points on the coordinate plane. So, first things first, if I can get the pen. Scatter plot is a graph with points plotted to show a possible relationship between two sets of data. Scatter plot, if I can write. Okay, so this first problem here, it says graph a scatter plot to show the number of points scored by the football team. So let's just write down here, these are the number of games, and on this one, this is the score. Okay, so for this first one here, game 1, score 6. What would I do?
Go find 1, go 6.
Okay, but notice that the y-axis isn't numbered, so we should probably go by some sort of
5s.
5s. There you go. Sounds good. 5. And I'm just going to go 5, 15, 25, because this is kind of small. 35, 45, 55. Okay, so Cody, you said go over 1 and then find 6. So that's about right there. What would I do for the next one? Calvin?
Go over 2
Mm-hmm.
and then up 21.
Okay. And notice that we don't have a specific 21, so we just have to estimate, right?
Yeah.
Right, so it's about right there. Okay, so for the next one, someone else help me out with this one. Cody?
Over 3 and go up to about a little bit after 45.
So like right here?
Yeah.
Okay. And then the last one.
Go over 4,
Okay.
and then up around the 35, but down.
Yeah, so just a little under it. So just like that. Congratulations, you have made your first scatter plot. So, just from this picture, so imagine this little table wasn't here, what would you say about the graph right now? Like if you were just given this graph, could you say, okay, this is the number of games, 1, 2, 3, 4. At 1 games, they want about how many points?
6 points.
Right, so that's what scatter plots are. You go on one axis, they say 2, and wherever that next point is, that's where your estimate for that value is. So for this one, on the second game, they won 21 points. Third game, they won 46, and so on. So the relationship between these two sets of data, games and score, and these can be any kinds of things like temperature, time, money, anything you want, but the relationship between them is called correlation. All right, so there are 3 types of correlation. One is positive, and that's when both sets of data increases. So just like this one, as the number of games increases, the score typically tends to increase, except for number 4, but we will get to that then. The other one is one set of data values increases as the other decreases. That's called negative correlation. And the last one, when there is no relationship between the data sets, it's called no correlation. Alright, so this picture down here, what is it describing? What's the two descriptions on the top and side, or bottom and side, sorry?
Visitors to the daily temperature.
Mm-hmm. So just by looking at this graph, what can you say about it? Is one going up as the other is going down? Is one going, are they both going?
Increasing.
Both are increasing. So as it says, as the average daily temperature increases, the number of visitors increases too. Now, if both of these sets of data are increasing, what kind of correlation would it have? Positive, right. So there is a positive correlation with it. Now, just for example's sake, what would this graph look like if the average daily temperature was North Dakota weather, so like 30
The
to
number
40?
of visitors would decrease
Right, and why would that be?
because it's colder and people want to be like California or something.
Exactly. No one wants to be in North Dakota on the beach. That's just crazy. All right, so next one. Identify the correlation you would expect to see between the pair of data sets and explain. So your example is the average temperature in a city and the number of speeding tickets given in the city. So your two variables are the number of speeding tickets and the average temperature. So just what would you expect to see from those two?
Increase.
There be a positive relationship with them?
Yeah.
Why?
Because the more visitors you have, the more tickets you're gonna have.
But we're dealing with temperature, right?
Mm,
So what-
People want to go to a place cooler, so they're in a hurry.
no, I think it's more is
Okay. Those are pretty good reasons, yeah. I can, if it's hot somewhere, I don't want to be there, so I would probably get out of the flood.
If the average temperature drops so low that you run out of food supply, you can't go to the grocery store, then you just have to get there, otherwise you're not gonna make it.
That's possible, but that's really in-depth, but I like that. Okay, so what did you say, Michaela?
I said the no, like, whatever.
No correlation?
Yeah.
Everyone say that word for me.
No correlation.
Correlation. Say it again. Yeah. Okay, yeah, Michaela's right. There would be no correlation. Would be no correlation. Because, Michaela, why did you say that?
Because just because the temperature increases doesn't mean people will automatically start driving faster.
Exactly. Just because it's hotter or average temperature is colder, warm, or just blazing hot, that doesn't necessarily mean that people are going to drive faster or get speeding tickets, because the average temperature that's very baddie. Has nothing to do with speeding tickets.
Mr. Conlon, the average what?
Average temperature. Oops. everyone good with this? Does anyone have any questions about positive, negative, or no correlation? Okay. And then on the next side, we will just be going up until these pictures of the graph, so you don't have to fill in or worry about the bottom part yet. So, next part, we are going to be matching scatter plots with, or choose a scatter plot that best represents the relationship between the age of a car and the amount of money spent each year on repairs. So,
There's something about that, yeah.
Another example.
Oh, is there? Oops. Okay. Runner's time and distance to the finish line. Sorry. Negative? Why is that, Julia?
Because as they get, like, as they run faster, they get closer to the line, so the distance is decreasing.
Right, so I'm just gonna draw a picture, but if you guys want to, feel free, but you don't have to. So which way do we want? Do you want runner's time to be on the bottom? No? Okay. Okay, time. And then distance is up here, right? There we go. Okay, so runner's time. So if this is the race, this is just a straight line, the runner would be starting back here, right? Because she's not at the finish line when she starts, is it? So as she's running, so Julia, explain this to me again.
As she's running, she is decreasing in distance.
Right. So as her time goes on, and it probably wouldn't look like this, because she would probably need to stop and take a break, but as time goes on, her distance to the finish line decreases. And so you said it was negative, right? Right, so there would be negative correlation.
But we don't get to just say negative and positive and no.
Nope, you have to say correlation.
You have to
'cause if you-
explain also.
Yep. Yeah, so now there's that. Okay. As her time. As her time increases, she's getting closer to the finish line. Finish line.
Could we change that? I'm sorry, because you should use the word increases and decreases.
Okay,
So as her time increases, what's happening to her distance?
It's decreasing.
Her distance decreases.
distance. All right, is everyone good? Okay. Now we start doing matching. So choose a scatter plot that best represents the relationship between the age of the car and the amount of money spent each year on repairs. So, Noah,
Graph C. Graph C.
graph C. So explain to me what this graph is saying.
And it's saying that like the cost keeps going up as the year gets longer.
So
more years
more years,
and the price increases.
Okay, so you're saying that this graph says that as the years increase, the price increases.
Yeah.
But right here, or right there, this is 1 year, right? What's the cost of the repair for that one?
Oh,
Wouldn't that be what he's saying?
Hmm?
Wouldn't that be what he's saying?
Yes, right. Because this is negative correlation, and why is that, Julia? Yes, because it's going down. As this one is increasing, the cost is decreasing for this one. This one, B, as the number of years is increasing, so is the cost of repairs. But why would it be graph A?
Because it's already started in the negative.
And why is that a problem?
because you can't start at negative years.
Exactly. So that one's out, because you can't have negative years. If you could, I'm sure a lot of people would love to take years off their life and be young again. I know I would. And it can't be this one, because it's negative, right? You already explained that. So it is B. And why is that? You have to explain that too.
Because as the car gets older and you want to repair it,
Mm-hmm.
that it's harder to find parts.
Right. So as the number of years increase, what happens?
The cost for repairs increases.
Right.
It's harder to find parts.
Right. Cost of repairs increases. All right. Anyone have any questions on positive, negative, or no correlation? All right, and with that, we will stop there for notes. And I believe on Friday we'll get back to that, but you guys can now start working on your assignment. It is posted up there.